This question is telling there are two coherent sources. The ratio of intensity is beta. If they interfere, prove that I max minus I minimum divided by I max plus I minimum is equal to 2 times root beta divided by 1 plus beta. This is very clear. The two sources are of different intensity, so different amplitude. So we have a formula for finding the intensity of maxima or minimum or general intensity at any point on the screen with two different intensity light sources undergoing superposition. General formula is intensity at any point is I1 plus I2 plus 2 times root I1 I2 cos phi, where phi is the phase difference between the two light rays. For maximum intensity, the cos phi part has to be plus 1. So it will become I max equal to I1 plus I2 plus 2 root I1 I2. The cos phi becomes 1. Same way for minimum intensity, cos phi has to be minus 1. So minus 1 will be I1 plus I2 minus 2 root I1 I2. So we need to find I max minus I minimum. So when you subtract I1 I2 will go 2 root I1 I2 minus so it become 4 root I1 I2. So they can substitute. They told you intensity ratio is beta. So I1 by I2 is beta, or I1 equal to beta times of I2. Substitute instead of I1 beta times of I2. So I max minus I minimum equal to 4. I1 will go as beta times I2. So I2 will come out 4I2 times of root beta. Same way you can find I max plus I minimum. When you add both, this negative positive part get cancelled. I1 plus I2 repeated 2 times. So 2 times I1 plus I2. Again, using that value of I1 equal to beta times of I2. So beta times of I2, I2 comes common out. So I max plus I minimum will be equal to 2 times I1 beta I2. So I2 will come out 2I2 beta plus 1. Now you are ready to divide I max minus I minimum by I max plus I minimum. So it will be 4I2 beta by 2I2 beta plus 1. 4I2 root beta. Okay. Now this 4 2 will go, I2 will go. We'll get the demanded answer. 2 beta root of beta by beta plus